Greetings, math fans. All right, so this is Sequences in Series Part 2. And what we're going to do now is we're going to identify explicit formulas that are a little more complicated than the ones we've done before. So basically, we've done arithmetic and we've done geometric. Okay, we've done some even recursive. But we're going to kind of expand on that a little bit. And if I was teaching this in the classroom, I'm going to put something on the sideboard. So I'm going to actually write this out right now for you guys to copy down, and then we're going to get back to it later. So if I give you a sequence that looked like this, 3, 10, 29, 66, 127, 218, and 345. And I asked you to come up with a general term, no saluting required, but a general term that describes this sequence of numbers. Okay, this is actually really brutal. In fact, it's one that you just can't look at it and kind of figure it out because it's really complicated. It could be in terms of x or x squared or x cubed or x to the fourth or x to the fifth. It could be a combination of those. You know, x to the fifth, x to the third, x squared. It could be so many different things that this is kind of this is definitely a very difficult problem. All right, so I know some of you right now are thinking, I'm going to drop this class because this is like way too difficult. But as soon as you're done with this lesson, you'll be like, oh, this is pretty sweet. Maybe I'll stay in Mr. Gervis's class. Okay? So anyway, if you guys could, like I said, kind of keep this handy here a little bit, and we're going to get back to it, and I'm going to show you how to do it. So let's start out with kind of a basic one here. If I give you 1, 4, 9, 16, and 25. Well, you can recognize this is like 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. Okay, so let's write that down. So it's a sub n equals n squared. Okay? Now, let's look at a pattern here. If I look at the differences between these, the difference between 1 and 4 is 3. The difference between 4 and 9 is 5. Between 9 and 16 is 7. 16 and 25 is 9 and 20, and well, that's it. All right, then I look at the differences between these. Between 3 and 5 is 2. 5 and 7 is 2. 7 and 9 is 2. So it took me in 2 turns here. I was able to get a common, these are all common numbers. Or really equal, right? That's what I'm looking for. Equal numbers. Okay? So we'll take a look at another one. We'll just keep it on the same page here. 1, 8, 27, 64, 125. Now you guys should recognize these as, this is a sub n equals n cubed, right? Well, let's look at the difference between these. Difference between 1 and 8 is 7, and then 19, 37, 61. The difference between these, 12, 18, and 24. And the difference between those is 6 and 6. So it took us 1, 2, 3 times to get the same number. So you can even see if it's 3 times, it's going to be n cubed. It's going to be a cubic. And because it took 2 times on top here, it's a quadratic. Okay? So that's, obviously pretty easy just by looking at the some of the differences. But what happens if it's a little more complicated? And it was easy to identify it because you say, oh, 1 squared, 2 squared, 3 squared, 4 squared, or 1 cubed, 2 cubed, 3 cubed, 4 cubed, etc. But what happens if it's something like, let me clear this out here. What happens if the general form is a sub n is equal to 2n squared minus 5n plus 1? That would be pretty hard to determine that. Because it's obviously easy if it's just n squared because you just look at it and you kind of see it, or maybe n squared plus 1 or n squared minus 1. But if you have 2n squared minus 5n plus 1, this is actually pretty complex. All right? Again, don't stop the video and go to your counselor and drop the class. Let's continue on here. So let's actually use this equation. Let's come up with our first few terms. If I do a sub 1 is negative 2, so I'm plugging a 1 into this equation. I'm not showing my work here, but you can just plug it in. If I plug in a 1 here, I get negative 2. A sub 2, I plug a 2 in there, I get negative 1. I plug a 3 in there, I get 4, and I plug a 4 in there, and I get 13. Okay? So let's take a look at those terms now. Negative 2, negative 1, 4, and 13. Well, if I find these differences, difference between these two is 1, difference between those two is 5 and 9, and the difference between these is 4 and 4. So you can see, just by plugging the terms to check it out, to go from here to here, it's an x squared, and sure enough, it is an x squared. Well, I have n squared here. Okay, so it's a quadratic. So it's kind of cool. Even if it's something complicated, if you kind of test it out and you look at the differences, and it comes out to be, where it takes 2 times to find the difference, it's a quadratic. 3 times, it's a cubic. So let's even talk about that. If it's 1 time, it's actually d. It's arithmetic. You should have known that right off the bat. Okay, but x squared is 2 times, and we just look at the exponent, x3, x cubed. So this is, we're going to say quadratic. So we'll get rid of the 2 here. x3 is going to be cubic. X to the 4th is quartic. Like 4 quarts in a gallon. So quartic, 4 quarters in a dollar. And that's where you get quartic, okay? So anyway, it's kind of interesting that just if I kind of analyze this a little bit, I can actually tell a little bit what the degree of the, so this basically tells me the degree of the general term. Okay, and that's important. So let's actually let's take a look at this again here. If I was given, let's start from the beginning here, because we know our equation. We're gonna actually determine that by hand now, what the equation is, because it's a quadratic, but I need a little bit more to figure it out. Okay, so it's kind of a little bit longer process, not real difficult. You just kind of follow along here. Okay, so if I go through this again, 1, 5, 9, we already did this, and then 4 and 4, we know it's quadratic. Okay, so my function is going to be something f of n is equal to an squared plus bn. Isn't that Spanish? Bn plus c. Okay, we know it's going to be something. Again, it could be it's got to be something with an n squared, but it could be a 0 for a b, 0 for c. But it's going to be something in the form of an squared plus bn plus c. And so let's take a look at our first term. Again, we're using, these are terms. The stuff below is just to check it. Okay, so our first term is when n equals 1. All right, so we're going to say f of 1, which is n, and then I'm going to put a 1 in wherever I see n. I'm going to put a 1. So a times 1 squared plus b times 1 plus c, and that f of 1 is equal to -2. Okay, so if I simplify this, I'm going to put it on, just kind of write it on the side here. I basically get a plus b plus c equals -2. That's my first equation. All right, and then what I'm going to do is my second term, I'm going to say n is equal to 2. So it's f of 2, and I'm going to put a 2 in wherever I see an n. So a times 2 squared plus b times 2 plus c equals, and my next term is -1. So I simplify all that, and I get 4a plus 2b plus c equals -1. And then I'm going to do this for my third term. N is equal to 3, so f of 3 is equal to a times 3 squared plus b times 3 plus c is equal to, and there it is, the third term, equal to 4. So again, simplify that, I get 9a plus 3b plus c equals 4. So here it is, math fans. That is my systems of equations. Okay, I've got 3 unknowns, 3 variables and 3 unknowns. All right. One thing I want to point out, this happens to be a quadratic. If this was a cubic, so I had an n cubed, it would look like this. It would be f of n equals an cubed plus bn squared plus cn plus d. Okay, and you do the exact same thing, except now you would have, how many equations do you need to create now? You'd have to create 4. Think of how many variables I have. If I've got 4 variables, I need 4 equations. If I have 5 variables, I need 5 equations. Like this one, I only had 3 variables. I had A, B, and C, so I created 3 equations. Really, really, really important to understand that. Okay, so now I've got these 3 equations, and you guys hopefully kind of remember how to solve this. I'm going to kind of move this down a little bit here so we can solve these with a little bit more room. So I've got 3 equations. I think the variable that I'm going to eliminate is the c because it looks the easiest because there's a 1 in front of each of for the coefficient of c. So basically what I'm going to do is I'm going to multiply this top guy by -1 and then add it to the one below it. So I'm going to try and show my work here. -a minus b minus c equals +2, and 4a plus 2b plus c is equal to -1. And so I get 3a plus b, the c's cancel, equals 1. So that's one equation. And then let's get rid of, let's do the first one and the third one. So again, I'm going to multiply the top one by -1. So it's going to be -a minus b minus c equals 2. And then the bottom one is just going to be 9a plus 3b plus c equals 4. So I get 8a plus 2b, or not 2b, oh yeah, and the c's again cancel, equals 6. So there's my second equation. So now I have just a and b, and so I want to eliminate the b, right? I've got 2 equations, 2 unknowns. So I'm going to multiply this one by -2 to get rid of the b. So that gives me -6a minus 2b equals -2, and 8a plus 2b equals 6. And so we get 2a, the b's cancel, is equal to 4. So a is equal to 2. Okay? So a is 2. Plug back into one of the other equations. I'm going to plug it into the 3a plus b equals 1. So I get 3 times a plus b is equal to 1. And so I get 6 plus b equals 1. So b, subtract 6 from both sides, and I get b equals -5. Okay, so that's good. And then I'm going to plug that into the first one. A plus b plus c equals -2. So a plus b, so -5, plus c equals -2. So -3 plus c equals -2. Add 3 to both sides. C is equal to 1. So going back to, I have my a is 2, b is -5, c is 1. You can barely see this. I'm going to move this up just a little bit here. Okay, right on top here, math fans, right there, that was our general equation. Okay, so you can see that f of n is equal to, if I plug in a into there, I get 2n squared minus 5n, plug in b in there, plus 1. So that's, instead of saying f of n, I can actually say our general term. Let me erase that. I can just say a sub n equals that. And if you look back, I don't have it on my screen anymore. I don't believe. No, don't have it on my screen anymore. But if you look back at the original problem that I started out with, I just came up with this equation based on our sequence of numbers. Okay, based on -2, -1, 4, and 13, determining that's a quadratic, then using, again, right here with our terms, coming up with our first term, second term, and third term, okay, and then eventually I come up with this system of equations right here, these 3 equations. I solve them to figure out what a, b, and c are, so then I can plug them back into this guy right here, and this guy right here, and this guy right here, and I actually get my final answer right here. Okay? So that's kind of longhand. Am I going to actually do that on a test? Yeah, maybe. Certainly nothing more than a quadratic, because I'm not going to ask you guys to solve a 4x4 systems of equations. Maybe a simple 3x3. It really didn't take that long, okay, but you guys have to know how to do that by hand. In fact, I believe the first two problems of your homework are doing it by hand and understanding it, how to create the systems. Okay? So it's really not that bad. Just you just kind of be a little patient. So I know this looks a little complicated, and it's really not that bad. Let's just test to see if it works on a linear equation. All right. So that's my question here. Does it work on a linear equation? And basically a linear equation is, if you remember, it's just D, right? So here's your sequence of numbers: 5, 7, 9, 11, and 13. Well, you should have done this problem back in the day and said, oh, well, that's really easy. D is equal to 2. And so what you would have done, you would have said, oh, a sub n equals a sub 1, 5 plus d, which is 2 times n minus 1. And you would have done 5 plus 2n minus 2. So you would have gotten a sub n is equal to 2n plus 3. Okay? That would have been your answer. And that would have been the smart way to do it. But let's do it using our nice little friendly way, finding a systems of equations. First of all, I recognize the difference here is 2 each time. So because it's 2, it's definitely going to be linear. So I have f of n, my general equation is going to be f of n equals a n plus b. Okay? So when n equals 1, and I say f of 1, it's a times 1 plus b, or a plus b. It's my first equation. And when n equals 2, I have f of 2 equals a times 2 plus b, or 2a plus b. So these, and these equal my first term, 5, and my second term, 7. So now I have a systems of equations, a little bit easier because it's just a 2 by 2, but let's solve it here. So if I multiply this by, let's get rid of the b. It's usually easier to get rid of that last variable. So I multiply this by -1. I get negative a minus b equals -5. And here I get 2a plus b equals 7. So the b's cancel, and we have a equals 2. And then to find b, let's plug it back in the equation. So we'll do a plus b equals 5. So 2 plus b equals 5. So b equals 3. So going back to our general equation, this guy right here, if I plug it in, I'm going to say f of n equals an, which is 2n plus 3 plus b. And if you notice, math fans, this is there, and it's also right there. Now, obviously, which way you're going to do it, you certainly are not going to do it this long way here. You're just going to find the value of d and be done with it. But I'm not. If you're given anything more than a linear equation, you're going to definitely want to use this nice little friendly equation to come up with an explicit formula. Okay. So let's take a look at a couple other things here, because I know you're like, wow, that's kind of a lot of work. Yeah, but I want to show you how to use your calculator now. So let's clear this out here, and if I give you guys, let's go back to the problem we just did. So if I have 5, 7, 9, 11, and 13. Okay, if I gave you those that sequence, this is really a set of points. Okay, so just think of it as f of n. Right, f of n is equal to that, is equal to that, that, and that. And when n is 1, it's 5. When n is 2, it's 7. When n is 3, it's 9. When n is 4, it's 11. And when n is 5, it's 13. So I can think of those as like x, y coordinates, because right, when I say f of n, the n is your input, and the f of n is actually your output. So I can say f of 1 is 5, f of 2 is 7, f of 3 is 9, f of 4 is 11, and f of 5 is 13. Okay, so I can actually write those as coordinates: 1, 5, 2, 7, 3, 9, 4 comma 11, and 5 comma 13. All right, and what I'm trying to do is I want to see what these points look like. So why don't you guys pull out your graphing calculators now, and if you need to, pause it and go find your graphing calculator. But I have my virtual TI here, which I'm going to pull up, and you're going to start out with just your screen here, turn it on, and then what I'm going to do is I'm going to hit Stat. So Stat, which is right underneath the Delete button here. If you can follow my my pointer. Let's get the calculator completely in here. Okay, so it's Stat, and then you're going to cursor. Well, first of all, you want to hit this 5. The 5 actually sets. Let me tell you. I'll show you a couple things now. It's called the Setup Editor, and if you hit Enter, it actually clears everything up for you. So then when we're going to type in the data. See, hit Stat, and if I hit Edit, you guys should have L1 and L2. I'm just going to type in a couple numbers here. I want to show you what we can do here. Let's say I have all these numbers here, and let's say I want to clear all these numbers out. Well, if I go to the top and I hit Delete, Delete actually deletes the column. So you don't want to do that, but let's just say you accidentally do that. Let's say you hit Delete, and you're like, oh my gosh, L1's gone, what the heck? What you do is you just go to Stat 5 Setup Editor and Enter. And that, again, that kind of resets everything. It puts all the columns back in there. So now when I hit Stat and Edit, L1 is back in place. Okay. Now if I want to clear everything out of here, well, first of all, if I want to clear an individual term, let's say I want to clear number 3 out of here, I can hit Delete where 3 is, and see how it moved now where there's no 3 going up to 4, and I can hit Delete again, and it clears it. Now that's how you can delete an individual number. If I want to clear the column, I go to the top, I hit Clear, and then Enter. It doesn't delete the column, it clears everything in the column. So then I can start typing in things in the column. What we're going to do is we're going to make L1 is your X values, and L2 are your Y values. That's pretty typical. Okay? So let's check it out here. If I'm going to put 1, 2, 3, 4, 5 in the spot. So 1, 2, 3, 4, and 5. Okay? And then cursor over, and then I'm going to put the 5, 7, 9, 11, and 13 in here. All right, I already determined this is linear, and that's important because the next step, once you have the data, and by the way, that needs to match up. If this doesn't match up, that 5 and the 13 don't match up, and it's got one more in each column, or we got one more in one of the columns, it'll actually give you a mismatch error. Okay, so you got to make sure that everything's lined up, make sure your data is all typed in correctly too. So now what you're going to do here, it's Stat again, and I'm going to cursor over to Calculate. So just do a right arrow. And then you see what happens is if you look here, you have a choice of a few things. Number 4 is linear regression. Number 5 is quadratic regression. Number 6 is cubic. Number 7 is quartic. Those are the only ones we're going to use because if you go any farther, we can even look. Linear, it's just a little bit different. Natural log, exponential, power regression. Oh, there's log. Oh, it's logistic. Sine regression. It's all kinds of stuff. But we're basically, let's go back to here. We're going to do, in this case, it's linear regression because it's linear. We went down 1, so it's just x. So I'm going to do linear regression. Now what's going to happen is some of you guys are actually going to get a different menu here because you have a new operating system. That's fine. Just kind of pay attention to what I'm showing you guys in class. But basically, you're just going to hit enter, enter, enter. Make sure L1 is for your x and L2 is for your y. Just hit enter, and then you're going to finally hit calculate. And if I do hit enter, this is what it gives you. It gives y equals ax plus b. And again, if you have the new operating system, it's going to look a little bit friendlier for you, just kind of nicer. But basically, it's saying y equals, let me go back to that again. It's ax plus b, so ax plus b, and it's telling you that a is 2 and b is 3. A is 2, b is 3. Which means my equation, it calculated, is 2x plus 3. which is exactly what we found from our original problem that we did, right? 2n plus 3, x, n doesn't matter. Okay, so the calculator actually calculated the linear regression, or the regression, which is basically like a line of best fit. Now, I want to show you one other thing here too. If I actually if I want to look at like the points out there, okay, because I plotted points, right? I plotted 1, 2, 3, 4, 5 points, and I can take a look at those points. If I hit second stat plot and see how my plot is on here, okay, but we need to change it a little bit. So stat plot, and I'm just going to cursor down here, type, and I'm going to have just where it plots the dots like that. Okay, and then there's your x1 is L1, or your x is L1, your y is L2. Okay, and so I'm going to plot these points now. So if I hit graph, well, actually I hit zoom stat. So if we cursor down here, let me show you which one stat is. It's number 9. Oops, I went a little too far. Zoom 9. If I did zoom 9, there we go. I just plotted those points. You can even see it's linear. Okay, it's kind of cool. So and then what it does is it calculates the actual equation of those points as a nice little linear equation. Okay, calculator is very powerful, very, very powerful. So let's do a little more crazy problem here, and I want to show you just kind of how powerful it is. So let's close this up here and clear this out. And let's say I give you, well, we did this one already. This might have been one of our first example that we did by hand, the 2n squared minus 5n plus 1. So let me write this out. So we came up with y equals 2n squared minus 5n plus 1. Okay, that was the original problem that we were given. And remember, we actually had the data then too. So we had -2, -1, 4, and 13. And again, I can just write this down really quickly. It's 1, 5, and 9 is the difference, and then 4 and 4 is the difference. So we knew this was a quadratic. So what I'm going to do is I'm going to type in this data into my calculator, and I'm going to tell it it's a quadratic regression, and then it's going to calculate the formula for me. So it should give me 2n squared minus 5n plus 1. So again, this is n equals 1, 2, 3, and 4, right? So we're going to do 1, 2, 3, 4. So let's go back. Let's bring our calculator up here. I'm going to clear this out of here, and I'm going to do stat edit, and I have 4 pieces of data. So I'm going to actually go to the top here. I'm just going to clear this out. So I'm going to hit clear again. Don't hit delete. If you accidentally do it, remember setup editor. So I'm going to clear it, and then I'm just going to go down to the fifth one because I only have 4 terms here, and I'm going to hit delete. Okay, cursor over. Now I have 1, 2, 3, 4 for L1, which is your x values, and then I'm going to type in -2, -1, 4, and 13. All right, and then I'm going to hit stat, calculate. I know it's a quadratic because I already figured that out, and so I'm going to go to number 5. Just you can even hit number 5. Okay, and again, you have, based on what your calculator is, just go down to calculate, hit enter, and watch this. Oh, look at that. So it says y equals ax squared plus bx plus c. A is 2, b is -5, c is 1, which is exactly what this problem is. It calculated that for us. That is so awesome. It really, really is awesome. Okay, so but you got to check what it is first. You got to check to see, is it quadratic, is it cubic, is it quartic? So is it a 4th degree polynomial? And once you do that, then you can enter in your calculator and do the regression. So let's look at our first example, the very first one that I put on the screen. Remember the one that I said you were all going to drop? So let's take a look. 310, 29, 66, 127, 218, and 345. All right, and then again, the difference is 7, 19, 37, 61, 91, and it takes a little bit of time. You know, you got to do the subtraction. 127. I mean, I have it written down here already because I did the subtraction already. Okay, the difference between here is 12, 18, 24, 30, and 36, and then it's all sixes between these. So it went 1, 2, 3. So I know it's x cubed. It's cubic. So that's all I need. Is now I'm going to put our top numbers here in my calculator with n is 1, 2, 3, 4, 5, 6, 7. Okay, so let's bring our calculator up here again. So we're going to do stat, edit, and since we're typing in 7, so 5, 6, 7, and then let's cursor over and be careful, make sure you get to the top. Okay, and I could clear this out of here if I wanted. Let's go to the top, just hit clear. It's nice. So if I hit clear and enter, then they're gone, and I can just start fresh. So I'm going to type in 3, 10, 29, 66, 127, 218, and 345. Okay, so all matches up nicely. Again, make sure your data's in there correctly. If it's off by a little bit, one little number, the problem's wrong. Okay, there's no way you can get it right. Okay, so let's hit stat. Let's go to calculate, and it's we figured out it's cubic, so it's 6. Hit enter. And you're like, oh man. Well, wait a second. Okay, I got some weird stuff here. So first of all, if you look at it, it's y equals ax cubed plus bx squared plus cx plus d, which is fine. A is 1. B is negative 2.3. So let me write this out. B is negative 2.3 e to the negative 11. Well, this is really scientific notation. And what does this really mean? E to the negative 11 means move the decimal 11 places over to the left. So it's negative 0.12345678910 to 3. So I moved it over 11 places. What is this number really close to? It's pretty much like saying 0. Okay, so please don't write on an answer blank negative 2e to the negative 11. Okay, it's a small number. The calculator is just kind of giving a little error because it's trying to do a regression, which means it's trying to estimate what the graph is going to look like. And it's so close, but it's off by the smallest little amount, and so that's equal to 0. Kind of like if I have 1.000000001 or some crazy number where it's almost a number, I'm looking for the 1, guys. Okay, so just kind of keep that in mind, and don't don't give me weird decimals. Especially the problems I'm going to give you are relatively friendly. Later in life, when you actually have realistic problems, you might have more complicated, maybe with decimals, and then you write down the decimals. It's okay. So anyway, if I go back to our calculator here, I get basically y equals 1x cubed, so x cubed plus 2. Right? Everything else, that 7.6 e to the negative 11 is also 0.00076, so that's also 0. So y equals x cubed plus 2. So this is it. A sub n equals x cubed plus 2. That's it. That's all all those nasty numbers, and that's what it is. Well, let's just to check it, just to do that. Okay, if I put a 1 in here, and I know I have an n, it doesn't matter, a sub x. Okay, but if I put a 1 in here, 1 cubed is 1 plus 2 is 3. If I put a 2 in there, 2 cubed is 8. 8 plus 2 is 10. If I put a 3, 3 cubed is 27. 27 plus 2 is 29. 4 cubed is 64 plus 2 is 66. 5 cubed 125 plus 2 127. You can see it's all working here, guys. Okay, 6 cubed is 216 plus 2 is 218. Okay, and then the 345 works as well. Okay, it gives you, I believe, 343 plus 2 is 345. So anyway, your graphing calculator is like awesome, very powerful thing to try to figure out an explicit formula. Okay, so that's what pretty much the homework is all about. It's just a bunch of problems where you have to figure out is it quadratic, cubic, quartic, linear, and come up with an explicit formula. Like I said, a couple of them by hand, and the rest of them using your graphing calculator. But make sure you know how to do both. Okay, make sure you know how to solve, 3x3 systems of equations, and you'll be good to go. All right, that's it, math fans, for day one. Have an outstanding day. Adios. Goodbye.